This conference will now be recorded.
Welcome. Welcome to the another session of CS1. Before we start the program, the session, just want to let you know that I grade all of your labs. There was two of you there was finally one of you who submit the lab last night, but two of you did not submit the lab. So I want you to pay attention to please pay attention on your submission. Your submission, you have to submit the .java file. Please do not submit the .class or the .class with the tilde at the end. It has to be .java. Two of you submit a docx. Okay, I graded it, but this is going to be the very last time I'm gonna accept a docx. Docx will change the font, not only the font, will auto correct most of the code that you have because they believe that you lost uppercase or lowercase. They put commas where it should be. It's gonna make a different changes to your code. So please do not submit docx. You need to submit .java. If you don't have a compiler or you have a hard time submitting something in .java, send it .txt. This is the extreme of the extreme, okay? And you will receive a note from on my behalf saying why you did not submit with .java, okay? So that's under certain circumstances. Maybe you don't have internet or something happened. So that's that. Please be aware of that situation because there's no way I can run it with .java. Okay, there's a way, but I'm not going to do that thing. The course is computer science. You need to follow algorithms, sequence steps, right? And if you cannot do that simple step, then yeah. So please do so. It's very important for you guys to follow the instructions. Otherwise, it's gonna be a little bit challenging for me to explain this. The second thing is that tomorrow I will post a quiz on the Blackboard starting at I'm not so sure when I start. I think it starts at 4 a.m. and it will close later during the day before the day ends. So so you have enough time for you to budget your time for to do your quiz. And there's gonna be a test on Friday, I think. You need to check the schedule. I think it's on Friday. So tomorrow is Tuesday. I'm sorry, Wednesday. And on Thursday, I will be posting a study guide that you need one, but in case you think you would like to see a little bit more material to see where exactly you should focus, you know what? I'll try to do it tonight. So they help sometimes. So those are the announcements that you need to recognize for the next logistics. We're gonna finish if statements or the chapter on conditional statements, most likely tomorrow or the next session. Yeah, I'm not so sure how you actually budgeting this videos, but in the next section, I will just talk about how to put things together in if statements, and then I'll start with iterative structures, which you call it loops. Yeah. Some of you already submit your lab number 2, which is due, I think, tomorrow, and also some of you already submit lab 3. I'm very impressed on that. That means that you've been working hard in the lectures. It's completely feasible, right? It's just a matter of how you pace your reading. So I think there were 5 students who submit lab 3. I'm very impressed because it seems to be that most of you are pacing in a good way, and some of you are pretty advanced already. Some of you are submitting in your labs. nothing against creativity, right? Some of you are very creative the way you put things together, but some of you are incorporating complicating things in a very simple assignments. Please avoid that. Yeah, avoid that because you're not following the instructions first of all, and then when you incorporate if statements and loop in lab one, that shows me that you kind of know a little bit more than what we're usually doing in the class right now. But please just submit the lab as it is. If you want extra work, just let me know, Professor. This class is a joke, right? I'm so bored. Just give me more work. I can do that. Right? But in the labs piece, please, always submit what I'm asking you, because if you're not following the instructions, I will have to penalize you with points off, okay? But if you think you're getting bored, that you want something more challenging, send me an email. I will be happy to give you more work, right? Whatever that means. But I like to see people who are active. And if this is something a little bit slow, and you want something to speed up, I can definitely give you the advanced assignments, because for every assignments I have the beginning, the intermediate, and the advanced for each of those labs. So if you feel like you need more adrenaline, and I can definitely give you, but just be aware I'm gonna grade you on those ones as well. So, but challenging accepted. No? So just let me know beforehand, so I know which lab I'm grading and which individual is asking me to grade what. Okay, I like to do that by all means. If you have the spirit to do more work and to be excited in that, I applaud you that. So please do so. I'm reading my emails because I make usually every night I make notes of the students who send me emails about extra credit. I did mention about extra credit on the last video. I will keep you posted on a couple of ways to have extra credit. Isn't that so? Try not to just focus on the extra credit. Extra credit is only to help you when you're in the borderline between one letter and another letter, and sometimes it helps. But if you're doing very bad and doing the extra credit doesn't count. Okay, I just want to let you know that that's something that you should pay attention. Now, I do support ac activities that are happening in these times. Usually, I have my club, the computer science club, and we have different seminars in during the face-to-face. This whole thing has changed everything to us, so we're going virtual a couple of things. So one of the things that I told you that if you want to have extra credit is, of course, subscribe to the channel. Yeah, that you can see down here in the screen, and then subscribe. And I did mention that if you bring 10 friends that subscribes to the channel in order to disseminate this idea, yeah, I will give you extra credit as well. So, but have to be 10 friends of yours. So please, the problem is that YouTube, what it does, if you subscribe, you can subscribe, but if you don't have a name, it will go to a different repository. So how can I know there's your friends, right? But if at the end, in next week, if you tell me the following 10 friends of mine subscribe to your channel, then yes, I can go and search for them and say, these are the students. So I can give extra credit for this person. So that's one thing. The other thing someone told me about the social media. Social media, what I do is strictly only to submit small videos on how to code and how to make little snippets of code or programming. So if you follow one of those social media and comment, or basically keep track of that, then definitely I can give you credit. Also in the videos of YouTube, if you make a comment and then you start a conversation, those are indicators that I can give you extra credit. Definitely, yeah. Another way I will give you extra credit is in case we're gonna have a podcast this Thursday. I think it's Thursday, yeah. So Thursday, we're gonna have the part 1 on this series that we're running. If you go to the channel, you will see the other episodes that we have been discussing for the past months. But tomorrow, not tomorrow, on Thursday, June the 4th at p.m. Mountain Time, there will be a seminar, webcast, sorry, with we have a special guest on consciousness and computing artificial intelligence. In case you're interested, you need to go to that link and RSVP because these are gonna be through Zoom access. Only people who send the request will send the link and the password in order to access that on Thursday. If you attend to that in a live meeting, you can, it's through Zoom, right? So you don't have to participate by showing your camera, but you can send questions through the chat. So I will moderate that conversation, and I will keep asking questions back and forward to the presenter. And they're pretty fun. Yeah, we have done a couple of them during the past months, and many people like them. I try to pick the best topics on computing. In this case, we kind of discuss a little bit more into the area of philosophy. One of my interests, minor in philosophy and in analytical philosophy. So we go over those areas and those aspects, and we're trying to incorporate into the aspect of computer science. So they're pretty awesome. I like them a lot. So in case you have time, it's usually 1 hour, 1 hour and a half, depends. Just go there, shoot some questions, make a small summary for what you have learned and send it to me, and then yes, definitely extra credit for you. And another question is about, yeah, so I'm gonna answer a couple of those questions while I'm doing the practice and what you see in this, but I receive a couple of your questions. It's very interesting to receive your questions because all days I'm answering emails, and I have a notepad where I collect all the questions, and sometimes I answer them, and sometimes I tell my students, hold that questions, I will answer it tomorrow. Sometimes I answer those questions right away. But the interesting thing is that some of you are being sending me questions 2, 3 a.m. and sometimes I can respond, but sometimes I cannot. So this morning there was like 4 very good questions about the program that I'm gonna elaborate in this session. So I'm very excited about this class. I think most of you are highly motivated. This is completely exciting for me. So I prefer to have questions. You guys bombard me with questions about technical things. That makes me very happy, and then very excited to come here and record the sessions for you. So please keep doing it. By all means, you're not bothering me. The more questions you send me, the more I can see that you're engaged. And do not apologize, because some of you are saying, I'm sorry for asking you again. No, do not apologize. That's where you're here. I'm very happy to answer those questions. All right. So let's go ahead and start the session on, this is the second part on decision structures. Let me just close this real quick. All right. I'm just gonna share it like that. Hopefully you can see this. There. So this is the second part of decision structures, where we're gonna continue with Booleans, comparators, logical operators. Excuse me, those allergies. But we're gonna incorporate now, we're gonna discuss something called the switch case. We're gonna compare strings, one of the important aspects in order to answer lab number 3, and we're going to talk about the conditional operator, one of my favorite topics as well. So when we talk about the switch case, this is a different version about how to make a decision. We talk about the if statements, and when we have the else if in our context, when we basically have a variables that we compare with the conditional operators. We talked about that last time: greater than, less than, greater, equal, less than, or equal, equal or not equal. So those are the operations that we usually use, operators that we usually use in order to make a comparison and then result in a Boolean statement. Those Boolean statement is a statement that returns either true or false. And based on that, we make a decision in the statement. So if you remember the syntax, we have if, open parenthesis, and that Boolean condition. If that Boolean condition happens to be true, then you will execute the body of the curly brackets of the if statement. Those are the curly brackets and everything that is inside. If it happens to be that the Boolean condition is false, then you don't execute that body of the if statement, and then you jump to another possible condition. Can be an else if, can be an else, or can be nothing. If it's the else, would automatically arrive there because of the previous condition was not satisfied. But if it happens that is not satisfying, you have an else if, then you're gonna start checking all the else ifs until you satisfy one. Otherwise, we go to the else. So that's how basically we've been discussing that in the previous sessions. Switch case, you're also gonna make a decision, but not in that particular form. The way switch cases will work, you're gonna use a variables value. So you're gonna have a variable that controls the flow of the entire switch case in order to make a decision. And then you have this multiple options called cases or case. So you're gonna list all possible cases that you might occur in the switch. And each case will have a sections of statements, like if it's this thing, then do this. If it's this thing, then do this thing. I shouldn't be saying if, but the if is in the English part the way we're gonna describe this. Each case, you can see it, or you can kind of recognize it like an if statement with an equals. So one of the important things that you need to consider in this particular case is the keyword break. I want you to appreciate that I use the keywords with a different font. I'm not so sure if you can appreciate here virtually, but there's a different font. That's because I want you guys to recognize that those are keywords, and I should just put it in different color. Maybe that will be a better idea. So if you don't have a break, the break tell us, okay, it's time to go home. It will break that case and then we'll terminate the switch. If you don't have breaks, it will continue until all the possible conditions might be satisfied. We don't have else in switch case, but we have something called default. Yeah, and that should be in different font. I just noticed that. So that will help us to, in case none of the previous cases will execute it, then we arrive to the else. So let's go ahead and write a small program that demonstrates this switch case. I apologize. I have a couple allergies, very intense, and I need to start drinking tea or coffee, something. I'm not so sure what is this. I'm just gonna put on save. Oops. So what I'm gonna do, I'm gonna save this in my desktop. And again, I'm gonna import my friend Java util scanner. Have a main. Sometimes this thing likes to do it. Sometimes just make me look like a fool. All right, so let's start with the program that will give us the option to ask the user to enter value 1, 2, or 3, yeah? And then we're gonna, in a numeric way, and then we're gonna just print the word. So the problem is ask the user to enter 1, 2, or 3, and then provide the corresponding word spelling. For example, if user enters 1, your program shall display 1. That is the description that we want to do here. So obviously we need the scanner, and I call it input. I saw your labs, and you call it SC as well, or keyboard. I know that only reflects that either 1, you're reading your book, 2, I know which website we went to that tutorial, so that's fine. But I told you that I can recognize where you're coming from when you write your code. System.in, just for input. So we want to describe, we want to ask the user the instructions. We want to tell the user, hey, enter 1, 2, or 3. Or let's just be polite. We need that these days. So we're expecting a number from the computer user at this point. So we're gonna call it option because that's what the user gives us. And at this point, we need to use input.next int. We extract that information immediately. Now, option, at this point, it will be the variable containing it will contain the variable that will help us to make the decision flow in the switch case. And you remember in the slide that I mentioned, that variable will have a value that will be determined what to do inside of the switch case. So it starts like this. We're gonna switch the variable option. So here we're saying to Java option, it's the variable that will tell us what to do. So please consider to us to have some cases that will satisfy that option. This is what it's saying. So the first case, it can be if the user gives us 1. And then we put the colon. And then we're gonna system. And we're gonna spell you entered 1. So the next thing is that we have case 2, and then we're gonna say to Java, you entered 2, and finally case 3. You entered 3. Now, there's more, okay? There is more, and at this point, I just want you to see what's gonna happen because this code is incomplete, and for those who know me, I like to do this a lot. I'm gonna throw something that is not correct and we're gonna fix it together. Well, I guess not together because you're there, I'm here. So this is sad because I don't have my students face to face. So what I'm gonna do, I'm gonna compile I just moved to my desktop, Java C, and then switch example.java. I compile it, and this should compile, this compiles successfully. I'm going to run Java switch. And here we're asking the first question. Here we are on line 9, waiting for a response from the computer user. So you have 1, 2, or 3. Assuming you're a good computer user, you're gonna follow those instructions. Suppose that you enter the number 3 and you enter 3. Looks fine, looks normal. That's because I put the number 3. If we run this program again and we decide to enter 2, look what's happening. You enter 2, you enter 3, and that is not what we want. As a matter of fact, if we decide to put 1, you enter 1, you enter 2, you enter 3. And what is happening is that the variable option that we enter on line 9, when we switch them, it will come here to the case 1. It's like, oh yes, I am 1, I am the 1. So here we're gonna execute line 12, and after that, we're gonna continue with case 2, case 3. The only reason is because we don't have what we call the break. The break tells us that once you satisfy that condition, you get out. So if we're calling case 1, we're gonna print you enter 1, and then right after that, we will break. And notice that there's still also kind of like a, that is a, I'm not so sure if you can appreciate this, but it's a keyword. So the keyword break will tell us this will terminate our program. So every case that is provided for you, you need to have a statement, and then you're gonna have a break. Very important, very important. So having said that, also in case 2, you can have it. Also in case 3. Notice that this is, you don't have the break. Java will recognize the input as is case 1 or case 2 or case 3. Remember those 3 tables that we saw last time? That is exactly how Java is going to treat it if you don't actually provide the break. It's an OR, it's a logical OR. So here at this point, I'm going to save this program. I'm going to clear my screen, and I'm going to compile it again, and I'm going to run it. So, and please enter a number 1, you enter 1. Please enter a number 2, you enter 2. Please enter a number 3, you enter 3. Please enter a number 4. What's gonna happen at 4? So it's not 1, it's not 2, it's not 3. What's gonna happen at 4? Nothing. You can leave it like that if you want to. Dangerous. For many different reasons. If you're interested to see why, I recommend to check a couple of videos on secure coding. So when you don't have case 1, case 2, case 3, we don't have an else, but we have something called default. The default says, hey, if none of the none of the conditions got satisfied, I'll take care of it. And the way and this is something that we're going to talk more in detail when we talk about next session on user verification. Yeah, is when you have to handle situations when you don't really have that possible implementation, or you don't satisfy that condition. You need to have an else in case none of those previous answers were the correct ones. So here we politely said, please try again with correct possible answers. So the question is very important. Please enter 1, 2, or 3. Yeah, you're asking the user in a very nice, polite way to please give you a number, 1, 2, or 3, and the user decide to give you 4, maybe by mistake, maybe unintentionally, or maybe was intentionally to see what happened in your code. You will have that a lot in computer programming. You might have a program that does exactly what your job is requesting to do it, but there's going to be a couple of individuals who want to see what happens if we try this. They can be teachers, they're called penetration testers. They can be good people, it can be not so good. Some people call it hackers. We'll see. So that's something that we should need to consider, right? Please enter 1, 2, or 3. Suppose that it's 1, suppose it's 2, suppose it's 3, suppose it's 7. Please try again with the correct possible answers. And that will gives the computer user that feedback when you enter the information, like, oops, I made a mistake, right? It's like, whoops, these guys they know how to program this. So we don't know. So we'll see how that goes. But this composition of statements are important in software development, software engineering, and you need to make the habit to start making those deals into your programming. So I apologize about that. Let's run another program that uses a different kind of type for switch case. I'm just gonna copy and paste this because I'm very lazy, and then I'm gonna save it here. But here I'm gonna change it maybe differently. We'll save this as this. And I'm gonna clear my screen. Okay, so there is a couple problems in your book that I recommend to do. This is one of the questions that I received last night. How can I improve my programming skills in addition to those labs? In the back of each chapter, there's something called programming challenges. I recommend to go and do those because I like them a lot. I think it's a very good book. I like it a lot. The main reason why I like this book a lot is because there's plenty of code there that they show you how to program something very simple and then escalate a little bit more difficult, more challenging, let me put it that way. But in the back of the chapter, there's something called programming challenges. I recommend to do those, in particular number 7 and number 13. If you have a chance to take a look at that and then do those, I recommend to do it. Let's ask now the computer user enters a character. I think I forgot to mention, yeah, I forgot to mention in this slide. I forgot to mention in the slide, the switch case was originally designed to work with three data types: integers, characters, and bytes. Integers, we've been working since day one. Characters also. Bytes, not too much, but you recognize that those are a primitive types. It's one of those primitive types. Now, what's in common a integer, a character, and a byte? All of them are numbers. And you probably remember that table. And let me just show you right now. Yeah, okay, it's because I did two different sets of slides. Because of my technical difficulties, I thought I lost everything. And then I realized that I'm a computer scientist and I know how to recover it. But anyway, so I have that. And this is the other set. So the variables could be integers, characters, and bytes. Yeah. In the new version of Java, actually, this is true for the past almost 2 years. Summer of, yeah, I guess it was summer 2018, that the string became one of the possible ways to incorporate into the switch case. So the switch case works ideally with these three data types. And now because we want to provide flexibility and because Java is widely known in the world because the string, they decide to incorporate it. But ideally, it only works with these three. It was designed because, and I hate to use this word at this point of your life, is more effective, more efficient. And the reason why is because there's a course that we will talk about efficiency. It's called data structures. And at this point, you don't care about efficiency. Please don't care about that. Please care. So if you have an extra time to go and see what is considered to be effective or not, please do so. We don't use doubles. We don't use logical ands. We use booleans. And the reason is because the switch behaves as an indicator for those primitive types because we deal in a number way, numeric way, in the machine, in memory. Why strings then? Because strings are a collection of characters. And if you remember that table that I show you, I forgot when, let me see if I can still, I thought it was in the same. If you remember this table, every character that we deal with, every character that we deal in the machine has an assigned numeric value, an integer. Yeah. Bytes are zeros and ones. Strings are a collections of zeros and of a collections of characters, which you can be reduced to a number. So that's why it's a reduction of concepts that you can have there into consideration. That is the main reason why strings work, and because there's just a collection at the end of the day of characters. So I want to elaborate through a different video, a different session on how to do a corresponding example with characters. So we're gonna ask the user again, input from the computer user. And we're gonna request to enter possible, so the problem is, please enter suppose that we're writing a voting system, right? Please enter R, D, or I. So R means Republican, D means Democrats, I mean independent. So we're gonna use you vote something, and I'm gonna cover a couple items here. When you ask the user, please enter these things, these three possible options. I put the square bracket that because that's an option to give to the user. You probably have noticed that in my labs. And what we can extract from the computer user at this point, you might think is a character, but it's not. Because scanner doesn't have, check this out, you have next line, next int, and I think there's next double. You see, this gives us next is a string int, and that's it. Yeah, you have short, long, int, float, double, byte, boolean, big decimal, big integer, and that's it. There is no next char. So what we're gonna do, we're gonna extract, I want you to recognize that I'm asking for a character and there is no next character. There is no method for that. If you go back to that page on chapter 2, there's no next character, next char. There's only next line. And that will be a string. So this works. You will extract the string. But I want you to make a decision in characters. And that is not how it's gonna work, because the switch, I don't want it to be option. I want you option with string. I want it to be a selection. And selection is basically the character corresponding to this string. So there's a couple of things that we're gonna do at this point. We're gonna pre-process a couple of users' input. The very first thing is that we need a character called selection, and it's gonna come directly from option. So option, you have, remember that in previous one, it's called char at. So char at will extract the character that is in this string. So here we're gonna cover 0. So basically we're gonna enter in line 7 the string representation of the option R, D, or I. And then on line 8, what we're gonna do, we're gonna extract the character, the particular character that is in that position 0, because that's the only element that we have there. And that's where we're gonna have the selection as the way to deal with. Professor, why you don't just leave the options? We can just leave option there, and this might work because now Java supports strings, but back in the day didn't support it. And I want you to understand why I'm gonna make this detail here. You probably won't understand that until you take the course data structures, and you will say, oh, a character is probably is faster to process rather than a string. And the answer is correct, but that's is in 1 year that you will take. Well, I guess whenever you take that course. So we're gonna have 3 possible cases. If the user gives us R, if the user gives us D, if the user gives us I. Okay, so suppose that user gives us R, suppose that you're creating a voting system. Here we're gonna say you vote Republican. And then we're gonna do the same thing for Democrats. Independent. I'm just gonna put the test. I don't know why it's not indenting. And of course we need the breaks. We break Republican here. And maybe it's easy or it's convenient to have a default. And then we kindly suggest the user or maybe we can just let them know invalid input. That's another way to notify the user that whatever the user gives us is not the correct one, okay, or invalid input. Now, the reason why I'm demonstrating this is because now we're comparing characters. Remember, in the very first videos, the characters are determined with a single quote. Strings are double quotes. Here is single quote. So I want you to see how this works in this sense. So I just saved my my program, Java compiler switch case example 2. I compile it and I run it. Please enter R, D, or I. Suppose that we enter D. You voted Democrat. Suppose you enter I. You vote Independent. Suppose you enter R. You vote Republican. Suppose you enter Z. Invalid input. So that is how you deal with that situation, with the situation of having or to extracting only character at position 0 from the string that you provided in line 7. So this is assuming that you enter a string. What do you mean with assuming? We can always put something like this. So sure if you can appreciate this thing. But I did enter something, the empty string, which has no character position, and I crashed the computer. I crashed the program. And I'll talk about that thing later on under a different series called secure coding, and that actually we deal with this kind of situation. Now, if we run it again, and I put here little r, lowercase, invalid input, d, lower d, invalid input, I, lowercase, invalid input. So now we're facing a different problem. Now we're facing the problem that we're dealing with casing, with upper casing and lower casing, because whatever the user gives us or gives the option is asking us here to provide R, D, and I. And notice that the programmer specifies to be uppercase, but the user probably don't know how to pick or to put caps lock, or to probably misread, or I don't know. There's different ways we need to consider that situation when someone gives us different sensitivity or case sensitivity. In Java is case sensitive. I agree with you. So how can we do that, Professor? Can we just, there's multiple ways to do this, and I'm gonna make a variation of this particular problem. I'm gonna call it 3. You know what? I'm gonna call it 2A because it's the same problem but with a variation. There's multiple ways to solve this problem. Maybe the user give us lowercase r, or remember that I use that, or lowercase r. Did I say uppercase? Maybe it's uppercase r or lowercase r. So you can start stack them. So we have the case, and then we have a stack them through all possible cases that belong to the same answer. So here we have uppercase r, lowercase r. Here we have uppercase D, lowercase d. Notice the quotes. Uppercase I, lowercase I. So that way you can actually consider multiple ways, multiplicity of different stages of the entire input that corresponds to the same answer. It can be R, it can be lowercase r, uppercase R. So let me just save this. I thought I save it. No, so I'm just gonna save here to A. I'm gonna go to my terminal. I clear it up. I'm gonna compile the program to A, and then I'm gonna run this to A. Please enter RD, all right, lowercase d. You enter Democrat. Please enter RDA, uppercase d. You enter Democrat. See that both of them, lowercase and uppercase, belongs or corresponds to Democrat or Republican or Independent, right? So that's how important it is. That is by creating stackable options. Remember that if you don't have a break, or if you don't have a break between cases, it's considered to be logical OR. The user gave us R or R, uppercase D or lowercase d, uppercase I or lowercase I know it sounds a little bit stupid the way I'm saying it. That is the way Java recognizes. When you have stacks like this, they're considered to be logical OR. Let me give you another variation of this. So this will be B. Suppose that you don't want to provide, the stacks. It's like, you know, professor, that's too much lines of code. Okay, you can consider that. And that part, if you decide to consider not to go through the stacking, I'm reading a couple of the questions. Another observation that someone in the chat is giving to me, Professor, can we provide R or lowercase r to specify the user? I have seen something like this. Please enter R or R, D or D, I and I, right? I have seen that. And I know what you're thinking. Yeah, this is called, there is a concept in computer science. There's a class called user interactions, right? That you try to give the most simplistic to the user to recognize what you're trying to do, right? You cannot assume that the computer user will think the way you are. I'm elaborating this because I like this topic. It's called user interactions. Even R or D or I, it's a little bit cryptic. Of course, that's what I say. Suppose that you're creating a voting system, yeah? But if you give this to Granny on, I don't know, on May or June, Granny's like, what the heck is R? What the heck is D? What the heck is I? So, but in a voting machine, that makes sense, right? When you go and vote in November, which I hope everybody go votes or send by mail, you're gonna know what R, what D, and I will actually represent. So that is the reason, and that's called contextualization. And thank you for sending that observation. You can. To be honest, for me, it's a little bit confusing because it's too much text. The less text you provide, the most clean and understandable it is. But it's a very good observation. I appreciate that feedback that you're providing. So you can do that thing in case you would like to give very detailed, but there's a cost for that. Text intense give us we have to pay the cost of confusion there. So here, suppose that we want to have only capital letters. So there's a way when you extract on line 7. On line 7, we extract the information And before we create the selection part, we can do something here. Option is going to change, yeah, because a variable is a placeholder which is value eventually change. So now it's going to change. So option is a string. So what we can create, we can send everything to uppercase. So whatever the user gives us, it can be uppercase or it can be lowercase. I don't care. We don't care. We're going to transform it into uppercase and we're just going to override option. If you don't like to do that thing, you can create another variable and you can use that. And then what you're going to do after that, everything is at this point uppercase. You just extract the very first character and you leave it alone, the switch. The switch case will remain the same. This is the way we're going to deal with that. In case you don't want to deal with stackables part, pre-process of that. There's a cost of this, which is that you're dealing, or you're actually messing with the integrity of the computer user gives us. On line 6 and 7, you're requesting a valid user's input. And whatever the user gives you don't care, you're just gonna transform into uppercase. Dangerous, yeah, but in this kind of code, it's okay. You have seen this kind of situation when you request to enter a password and the password owns a complexity with lowercase, uppercase, numbers, a combination of special characters, God knows what. So the reason why those features are being incorporated into the password generation is because they're more difficult or more challenging to hack or to crack. So there is always a cost for everything in computer science. You want to be simple for the computer user, there's more work that you have to do. You have to be more detailed with the computer user input, there's less work. So the question is to find out the balance between what exactly is better for the computer user in certain circumstances and what is better for your programming language and in the computer system requirements. That is that. So with this, we'll conclude a couple items. We not only saw how to deal with switch cases, but also user's input and how to handle that computer user input. Thank you. So one of those things, the next concept is about dealing with strings. Okay. The next topic is how to compare strings. You probably see a couple of my comments here. So comparing strings using methods and so we're going to compare strings by using a couple of methods and we're going to interact with the computer user. So the next topic is about how to compare strings in Java. And at this point, you probably know how to compare them, basically integers, doubles, characters, by using any of the 8 primitive types with relational operators. We talk about relational operators: greater than, less than, greater equal, less than equal, equal, not equal. We have that. We're going to demonstrate why it's not necessarily possible directly with strings. So I just want you to understand that we've been introducing the concept of objects a little by little, and string is the main object that we always discuss, that we always reference, because it's the most simple way to demonstrate objects and its functionalities. Also, scanner is another object that we've been using. That's how we extract the next in, the next line, next double. Everything that you deal with methods or functionalities like dot next something to uppercase dot length, they're considered to be methods for specific objects. So that's why we have different strings, different objects, sorry. So that equals is another method that we're going to use in string to compare equality in content between two strings. The equal sign, the double equal sign or operator in strings, in the context of strings, compares the location in memory location where the string is located. And at this point, probably you don't care about location, but it's important to recognize that in the fundamentals in computer programming, everything gets stored in memory. In your machine has a RAM when the information gets stored. The double equals compares that location. It's a little bit more complicated. We're going to talk about that later on. When we talk about two-dimensional arrays or arrays. But that is when we touch the elements on that. Um, compared to is a different way to compare strings, not by equality or by content, but something called ordering, called lexical graphically order. This thing should be in italics. So that's a big word. Lexical graphically order, it's basically the order that is being assigned, and you probably know there because according to this table. So the lexicographically order follows the order of the ASCII table. It's kind of safe to say that it's in alphabetically order at this point, although I'm gonna take it back in a couple of more lessons. But lexicographically order, you can associate it with alphabetically order, although that is not necessarily alphabetically, because for example, you can see uppercase A starts in the decimal value of 65, and then you have some special characters here between uppercase and then lowercase, and then you have the lower cases. Before uppercase, you have the numbers, but between the numbers and the uppercase, you have more special characters. So it's not alphabetically ordered. It's lexical graphically ordered, based on the lexica, based on the ordering that is being assigned according to the syntax. So let me just give you an example that by using interactions. I just want to make sure you can see. You cannot. Again, I'm using Dr. Java only because I want to interact with the computer user. I like this because it's easy, clean, and fast to demonstrate. Suppose I have a string X. Hello. And suppose we have a string Y. Excuse me. Hi. And suppose we have another string Z. Hello. So we're going to use this X. Is X the same as Y? Obviously, it's false, professor. Is X not equal to Y? That is true. They're not the same. Now, this is what is going to confuse you a little bit more. is X the same as Z? In your heart will say, that is true, professor. X is hello, Z is hello, therefore true. And this is where I break that heart because it's false. And this goes back to the concept that I just mentioned, the double equal signs. It's the actual location in memory. That's where you use the double equals to check the location in memory where the string X and the string Z are being located. And this is not the case. Here we want to compare equality. If you want to check equality, you need to use is X that equals to Z. And that is true. If we put X that equal to Y, that is false. One is hello, one is hi. I can create another string W that will look like this. What is X? Hello. What is W? Hello. Can I do is X double equals to W? This is the difference for checking reference in memory and checking content. I know X and W, they're the same content, but also that was X and Z. The only difference here, what I just did in this statement, I'm asking Java to create a string called W that will get the reference of X. So basically, whatever X is pointing to, W will say, me too. So here, that's why the location is being changing there. And that takes also the content, but also the location. I want you to recognize that there are multiple ways to do that. And I cannot extend my screen, can I? No, it's probably blocked. It actually froze. So, all right, so I was able to do it. So here is the example of how to determine this part. So, you know what's a matter of fact, why I don't just take a screenshot of this, and I'm gonna elaborate this in the website so you guys can have a little bit, basically what I just said in terms of coding. So the equal signs is not the same as that equals. And I need you to pay extra attention on this because most of you will make a mistake in the lab or in the test by using the double equal signs instead of the dot equals. This is a typical mistake that I see a lot in my students' test because they don't know how to recognize the difference. Sometimes I have seen students that they don't know how to recognize between this sign and this signs, the composition of these signs, or how to use that equals. But remember that this is not called equals, this is called gets. So I invite you to go back to the first video that we talk about the difference between the gets and the equal signs. So this will demonstrate how to compare content of equality. The next thing that I want to demonstrate, I'm gonna reset this real quick. But I'm gonna create another string called X Apple. And I'm gonna create another one called orange. Obviously, X that equals to Y is false because they're not the same content, but now I care about lexicographically order. Which one, if I try to order them, which variable goes first and which one goes after? X or Y? So can I do, is X greater than Y? And when I type this thing, you might think maybe it's true, maybe it's false, because Apple has less characters than orange. Is false because A goes before O. I don't know. There's a couple of they are running through your head, and all of them they're wrong because you cannot compare two variables, strings, using conditional operators. Remember those 6 conditional operators that I talk about? Those only work with the primitive types, not with strings. So the conditional operators, they have no impact in this particular context in strings. So how can we compare them? And there's something called compare to. So we can say x dot compare to y. Compare to is a, as the word says, is a comparator. It compares lexical graphically order between two strings, but it's not the strings, it's the characters that appear in the string at specific stages. So for example, if I do this, is going to give you a number. Here is giving you -14, which in your mind means nothing. But in Java, basically it tells you 2 things. It gives us a sign, positive or negative, and it gives us a number. And I'm gonna go back to, I'm gonna share my screen. So this, and what the compare to is comparing the characters on the very first occurrence. For example, apple, which is in X, it corresponds to the lowercase a. Here I'm not so sure if you can see it, but it's in my cursor to the side. Apple starts X, and then orange is O. How many characters are between A and O? Let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Does that number rings a bell? There's 14 characters between A and O. Because that tells us that there's 14 characters between A and O from apple to orange. What does the negative means? It means that the left-hand side character in the left-hand side is, or its negative means is to the left of the right-hand side value. What do you mean, professor? It means if I do this, is y dot compared to, that tells me positive 14. That means that the value to the right-hand side, it's greater. That means that correspond closer to the value that you're comparing to. So y dot compared to gives you 14. X dot compared to y gives you -14. Very important concept. If you want to visualize that, means that the letter that is into the left-hand side to the y is in order. That means that A goes before O. And positive means that O is positive, that the right-hand side should go is to the right to the left. So suppose that we have another string, Z. And we have another one called I'm sure there's a lot of words that start with A, but I want to do ape. X is apple, Y is orange, Z is ape. So when I compare X dot compared to Z, what value is going to give us? Because X and Z, now we're comparing X and Z. A, how many letters or how many characters are between A and A? None. 0. So Java, what's gonna do is if it's 0, then it's gonna move to the next character, P and P. How many characters are between P and P? 0. So that means that we need to go and search for the next one, which is P and E. How many characters are between P and E? And probably there's a few, right? But X is P and E is Z. So very first guess, what will be the sign of this guy? Positive or negative? It's going to be positive, right? Because P is alphabetically ordered, graphically ordered, goes after the letter E. So at this point, I know it's going to be positive. How many characters? I don't know. You see the E, F, G, H, I, J, K, L, M, N, O, P. So 11, right? So that's 11 values positive, meaning that there is 11 characters at P and E. And yeah, the value in the left-hand side should go to the right-hand side, positive of Z. That's what really means. All right, Professor, that's kind of cool or weird, but and so what? If you want to order them, and that's what I told you earlier in this video, I recommend you do some of those problems in the back of the chapter that basically this problems of that. When you want to order which one goes to the left and which one goes to the right, when you do x dot compare z, now this will give us a number, a whole number, an int. An int is a primitive type. Therefore, now you can use relational operators. So here we can see now greater than 0, true. So basically we'll read the following. Hey, is apple greater than ape, lexicographically order? True. So in order to program that, you need this statement. Is x dot compared to z greater than 0? And because I already explained, because this whole thing, it gives you a number, and we want to compare with numbers using relational operators. I think I mentioned conditional operators. I really meant relational operators. That will give us a Boolean statement, which is what we want in an if statement. So this is the way you compare them. So can I compare now X and Y, apple and orange? Is apple greater than orange? This is what I'm trying to say in programming. False. Orange is larger, or orange is greater in the alphabet, in the alphabetically speaking. Lexicographically order has more values towards the end. So this is the way we compare those using strings. A very important concept for you to recognize when you're trying to do your programs. And if you have any questions, please let me know. All right. The very last topic that I'm gonna cover in this session is the conditional operator. And the conditional operator basically help us to reduce statements in our programs. And let me I'm gonna pull up this code that we did. I'm not so sure when you actually start watching these videos, but basically we I save it in a different directory, that's why. Yeah, this is a good Sorry about that. Oh, that's why. Okay. I need to stop sharing my screen here. And I'm gonna start sharing something else, which is this. Remember those good old days when we wrote this cute little programs and everything was happiness? And I mean, everything is happiness at this point, but look how cute was that program, right? So what we're gonna do here, we're gonna introduce the conditional operator, and the conditional operator is composed of two things. Actually, I should just share my screen here so you can see what I'm gonna write in there. This is the conditional operator. All right, the question mark and the colon. So the question mark represents the if statement is true. The colon corresponds that if the condition that you checked previously is not true, then I'm gonna handle the else. So basically, you usually have a variable that you will be assigned based of a Boolean expression. If the Boolean expression, I mean R, if it happens to be true, you can execute whatever is between the question mark and the colon. Otherwise, I'm gonna handle what is false and then semicolon. Maybe I should just reduce the size of this guy. All right, that is basically what we're gonna try to do. You will have a variable that will contain a value. This is very important. Many of you forget to mention about the variable, but it's gonna get a value based on the evaluation of this Boolean expression. If that evaluation of the Boolean expression happens to be true, yeah, then you will provide a value for that to this variable. Otherwise, this is where the colon is. It will provide the false statements. Having said that thing, I'm gonna go back to my code. And we can identify that variable that we want. Notice that we want to print something in both cases. If this is true, we're gonna print wear shorts and short sleeves. If it's false, wear some pants and jacket. So either or you're gonna print. So this is the way we reduce this code. And we're gonna put some message. I'm gonna put MSG. MSG is a string, as you can see, that will be part of evaluating this Boolean expression. So if the Boolean expression is a temperature greater than 75, if that is true, question mark, we will provide this wear shorts and short sleeves. If it's not true, question colon, otherwise, I want you to wear some pants. Okay, you know what? I'm gonna remove the wear because it's getting longer here. Yeah, and that is like that. So I reduce the code with that question mark and the colon. So that will shrink the entire code big time. And I should just save this decision example. I think it's 6. You know what? I'm just gonna call it this conditional operator 1. And I'm gonna save this differently. Save as. Like that. So I'm gonna clear my screen. Java C conditional operator 1. This compiles the program successfully. And then I'm going to run Java conditional operator 1. What is the temperature? 100 degrees, shorts and short sleeve, 60 degrees, pants and jacket. You see how nice is this, the way we reduce the if statement into just one line of code. We are saving 1, 2, 3, 4, 5, 6 lines of code just by putting it there. We're using the conditional operator. So this is very effective. I like it a lot. I have seen more and more people using this conditional operators, and there's an extension on that in new programming languages that they use this kind of syntax. Kotlin is one of them, not necessarily the way you're looking at, but it's the same principle. Again, the course is called Foundations of Computer Programming. I'm not going to show you exactly what all programming languages they do, but I'm going to show you how the principles, the foundations, are going to be when you see another programming language later on. And with that, this will be the last topic that we're going to cover in this session. It definitely shortens the program. So one of the questions is, what happened if it's 75? I discussed in different session. You need to be very careful if you're gonna include the 75 or not include. Yeah, so this is in case you want to include it, the 75 to be kind of to wear shorts and short sleeve. But if you don't want to include it, the 75, then it will go directly to the pants and jacket. Thank you for those questions. Remember that there's some announcements in the website and in the Blackboard. I strongly recommend to keep an eye on those constantly. During the entire day, I keep posting that information there, so please do so. And without that, I'll see you next time. Happy coding.